Here's a pattern you might have seen before. It's one that is very nice and easy to follow. It's what we call Pascal's triangle, named after Blaise Pascal, who discovered it. So Pascal's triangle. If you have a look at how it starts, the first term we start off is a 1, and then we have 1 1 again, a bit like other patterns you start to see around the place. Now, how we get the next line is 1 2 1. What we do is take the two terms above it, mediate to its left and right, and add them to give you that term. Now notice everything's basically, we're taking a 0 here, so that would be a 1. So every line down the side of the triangle is a 1. So, but then the other ones, 1 plus 2 gives us a 3. 1 plus 2 gives us 3 there. And a 1 plus 3 gives us 4. 3 and 3 gives us 6. 3 and 1 gives us a 4. And that's how we go down the line there. So we get some, if we have a look though as well and investigate around this line, we notice something happening with our patterns. And then if you have a look at each side of that line, you'll see that the Pascal's triangle is symmetrical. So it's important to recognize that we do have this symmetry about this triangle. But it's an interesting little pattern. Every term is given by the one above it. So 7 comes from the 1 and the 6, and then 8 comes from the 1 and the 7. 28 comes from the 7 and the 21, and so on. So 425 is 265, 330 added together. So we notice how we get those terms as we go through. There's a few typos as we go through, so just check them carefully. So what we want to look at next is, well, what happens when we complete these expansions? So we've basically gone in the 2-unit course up to this point. We don't really expand much further than that. So 1 plus x, so 1 plus x to the power of 0 is 1. 1 plus x to the power of 1 is 1 plus x. 1 plus x to the power of 2 would be 1 plus 2x plus x squared. Now to get 1 plus x all cubed, well, we take 1 plus x all squared and multiply by 1 plus x and then collect our terms. So you can do that as an exercise. Is to multiply 1 plus x times that, expand the values out, and then 1 plus x times this expression will expand out to that one. 1 plus x to the power of 5 will be this expression times 1 plus x. Now, hopefully you're looking at those and saying, well, what do you notice about the brackets? Well, the terms you're getting there will match up to terms in Pascal's triangle. So that's an interesting little situation, that the terms we start to see, it's at 1 4 6 4 1. 1 4 6 4 1, and we start to see that right the way through. So it makes it easy to start to use to expand these ones if we know Pascal's triangle. And that's where Pascal's triangle is going to come in handy, to be able to expand something like that without having to go through the quadratic and then the cubic and the quartic and the fifth term and so on. So that's what we're talking about when we're looking at Pascal's triangle and using the patterns there. So again, if we're going to expand a binomial like this, instead of 1 plus x, a plus x power of 0, well, there's 1. A plus x to the power of 1 is a plus x. A plus x all squared will be ax squared plus 2ax plus x squared. A plus x to the power of 3 is a cubed plus 3ax a squared x plus 3ax squared plus x cubed. So you start to see the binomial theorem starting to come into play. And the 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, and 1. So we start to see that come into play, and that's where Pascal's triangle is going to come in handy for our binomial theorem, because this is basically showing us our binomial theorem.